Today, we're diving deep into the heart of our solar system, the Sun. This blazing ball of plasma is not only responsible for our tans and sunburns, but also for providing the energy necessary for life on Earth. Think about it. Every leaf that grows, every breeze that blows, every wave that crashes on the shore, it all can be traced back to the power of the Sun. From its mind-boggling size to its incredible nuclear reactions, the Sun is a celestial wonder that continues to fascinate us. So, get ready to have your mind blown wide open as we explore some amazing facts and delve into the mysteries of this magnificent star. So, what exactly is the Sun made of? You might be surprised to learn that it's mostly hydrogen and helium, just like the gas giants in our solar system. About 74% of the Sun is hydrogen, the lightest and most abundant element in the universe. Another 24% is helium, the second lightest element. That leaves just a tiny fraction, about 2%, for heavier elements like oxygen, carbon, and iron. Now you might be thinking, hydrogen and helium? Those are gases. How can a star be made of gas? The key is the incredible pressure and heat found at the Sun's core. The Sun contains over 99.8% of the total mass in our solar system. That much mass creates a gravitational force so strong that it squeezes the Sun's core, generating temperatures of millions of degrees. At these extreme temperatures and pressures, hydrogen atoms fuse together, creating helium and releasing a mind-blowing amount of energy in the process. Let's talk about size for a moment. You know how Earth feels big? Well, get this, you could fit about 1.3 million Earths inside the Sun. That's right, the Sun is absolutely massive. To put that into perspective, imagine the Earth as a small grape. On that scale, the Sun would be the size of a large exercise ball. Its diameter stretches for a staggering 1.39 million kilometers. And the Sun's mass? It weighs in at a whopping 330,000 times the mass of Earth. This immense mass gives the Sun its powerful gravitational pull, keeping all the planets, including our little Earth, in orbit. And it's that gravity that creates the intense pressure at the Sun's core, fueling those nuclear reactions we talked about. Now, let's take a journey from the Sun's scorching core all the way out to its wispy outer atmosphere. Deep in the heart of the Sun lies the core, the nuclear furnace where hydrogen atoms are constantly fusing into helium, releasing that unimaginable amount of energy. Temperatures here reach a scorching 15 million degrees Celsius. That's hotter than anything we can even imagine here on Earth. Moving outward, we encounter the radiative zone. Here, the energy generated in the core slowly makes its way outward, carried by photons of light. It's a long and arduous journey, as these photons can take hundreds of thousands of years to travel through this dense, radiative zone. Next up is the convective zone, where things get really interesting. Think of a pot of boiling water. The hot plasma in the convective zone rises, cools, and then sinks back down, creating massive convection currents. Finally, we reach the surface, or what we perceive as the surface, the photosphere, which emits the light we see here on Earth. Now, you might think that as we move farther away from the Sun's core, the temperature would steadily decrease, and you'd be right for the most part. But here's where things get really strange. Above the photosphere, we encounter the chromosphere, a thin layer of the Sun's atmosphere visible during solar eclipses. It's here that we see those spectacular prominences, giant arcs of plasma that loop and twist above the Sun's surface. And then, extending millions of kilometers into space, we have the corona, the Sun's outer atmosphere, also visible during eclipses. Now, here's the kicker. The corona is much hotter than the Sun's surface, with temperatures soaring to millions of degrees Celsius. Scientists are still trying to understand exactly why the corona is so much hotter than the surface. One leading theory suggests that energy is being transferred from the Sun's magnetic field to the corona, heating it up to these incredible temperatures. Our Sun isn't just a giant ball of gas content to sit there and burn. It's a dynamic and active star, and its activity can have a direct impact on our planet. One of the most fascinating aspects of the Sun is its 11-year solar cycle. During this cycle, the Sun's magnetic field flips, with the north and south magnetic poles switching places. This magnetic flip-flop causes all sorts of dramatic events on the sun's surface, including solar flares and coronal mass ejections, or CMEs. Solar flares are like sudden, intense bursts of energy, releasing as much energy as billions of atomic bombs. CMEs, on the other hand, are massive eruptions of solar material, billions of tons of plasma, launched into space at incredible speeds. When these solar storms erupt from the sun and are directed towards Earth, they can interact with our planet's magnetic field, causing geomagnetic storms that disrupt satellites, communication systems, and even power grids. Let's talk about energy for a moment. The sun is an absolute powerhouse, constantly churning out an incredible amount of energy every single second. To give you an idea of just how much energy we're talking about, consider this. The sun emits more energy in 1 second than humanity has consumed in its entire history. That's right. The sun is a giant nuclear fusion reactor in space, converting millions of tons of matter into energy every second. And we here on Earth are bathed in this constant stream of energy. It takes about 8 minutes and 20 seconds for sunlight to travel the 93 million miles from the sun to Earth. Now, let's talk about those intriguing dark patches that sometimes appear on the sun's surface, sunspots. Don't let their name fool you, though. Sunspots are still incredibly hot. They just appear darker because they're cooler than the surrounding areas of the photosphere. These cool spots are caused by the sun's magnetic field. Imagine the sun's magnetic field lines as giant rubber bands twisting and turning beneath the surface. Sometimes, these magnetic field lines get so twisted and tangled that they poke through the photosphere, creating regions of intense magnetic activity. Like everything else in the universe, stars have a lifespan. They're born, they live, and they eventually die. And our sun is no exception. Right now, the sun is in what's called its main sequence, happily fusing hydrogen into helium and shining brightly. It's been doing this for about 4.6 billion years, which is about halfway through its expected main sequence lifespan. But what happens when the sun runs out of hydrogen fuel in its core? The sun will swell up to hundreds of times its current size, becoming a red giant, a stellar behemoth engulfing the inner planets, including, quite possibly, our very own Earth. Don't panic just yet, though. This red giant phase won't last forever. Eventually, the sun will exhaust its helium fuel as well, and its outer layers will drift off into space, forming a beautiful planetary nebula, a cosmic cloud of glowing gas and dust. At the center of this nebula, all that will remain of our once mighty sun is a small, dense object called a white dwarf. White dwarfs are the incredibly dense remnants of stars like our sun. They're about the size of Earth but contain a mass comparable to the sun, making them incredibly dense. Over billions of years, this white dwarf will slowly cool down, eventually fading away into a cold, dark object. We've explored the sun's composition, its size, its layers, its activity, its energy, and its eventual fate. But perhaps the most important thing to remember about the sun is its profound connection to life here on Earth. The sun is the ultimate source of energy for nearly all life on our planet. Plants use sunlight to photosynthesize, converting light energy into chemical energy, which forms the base of the food chain. The sun's energy drives our weather patterns, creating winds, ocean currents, and the water cycle, all of which are essential for life as we know it. The sun's warmth makes Earth habitable, providing the temperature range necessary for liquid water to exist, which is essential for all known life. From its nuclear heart to its wispy corona, the sun is a celestial wonder that continues to captivate and inspire us. It's a star that's given us life, sustains our planet, and will continue to shape our destiny for billions of years to come. So, the next time you gaze up at the sun, remember that you're looking at a star, our very own star, a giant ball of plasma that holds the keys to our past, present, and future.